Alright, so the first thing that we want to do is we want to isolate that radical. So we're going to get rid of this 2 that's attached to the square root by doing the inverse operation. So we're going to divide by 2 on both sides. And when we do that, we're going to get the square root of x plus 5. So then you're going to get 8 divided by 2 over here equals 4. So now what you want to do is you want to square both sides to eliminate the radical. So we're going to take both sides and we're going to square them. And that's going to give me x plus 5 on this side equals 16. So you got to make sure that you square it. You're not multiplying 4 times 2, you're squaring it. So that's saying 4 times 4. Okay? Alright, so then we want to get x by itself, so we're going to subtract 5 from both sides, and that's going to give me x equals 11. So that's taking me up to step 3. Now, step 4 says to check for extraneous solutions. The word extraneous means basically that it doesn't work in the original problem. Alright, so what you're going to do is you're going to plug it back into the original problem. Okay, so when you're checking, you're going to get 2 times the square root of 11 plus 5 equals 8. So, first thing I'm going to do is I'm going to simplify what's underneath the radical. So that's going to give me 11 plus 5. That's going to give me 16. And then the square root of 16 is going to give me 4. So that's going to give me 2 times 4, and that's going to give me 8. So since this works, so it's 8 on this side, 8 on the other, then what's going to happen is your final answer is going to be x equals 11. Now, if it does not equal, that means like this was negative 2 equals 8. That's not a true statement, so you're going to have an extraneous solution, and I'll show you that one in just a second. So on number 2, it's the same process that we just did. So we're going to isolate this radical by dividing 3 on both sides. Okay, and that's going to give us square root of 2x minus 1 equals 2. Step 2 says to square both sides, so we're going to take each side and we're going to square it. And that's going to give me 2x minus 1 equals 4. The reason why I'm going to get just 2x minus 1 over here is because the opposite of taking the square root, okay, so the opposite of taking the square root is to raise something to the second power. Okay, and that's why they cancel out. Alright, so down here, when we solve, we're on step 3. We're going to add 1 to both sides. And that's going to give me 2x equals 5. Still want x by itself, so we're going to divide by 2 on both sides. And that's going to give me x equals 2.5, or you can just keep it as 5 halves. Now, step 4 does say that we need to check for extraneous solutions. And yes, you have to check on every single problem. And the reason why is because sometimes it can give you something's not equal on both sides, and we're going to see that on, I think, example 4, but we're going to check this one. So if we plug 2.5 into my equation, let's check and see if that gives us the answer. So 2 times 2.5 is going to give me 5. Okay, and 5 minus 1 is going to give me 4. The square root of 4 is going to give me 2. And 3 times 2 is going to give me 6. Well, if 6 equals 6, then that means that my final answer is x equals 2.5. Alright, so on number 3, we're going to notice that there's this little, like, 3 in the little cubby hole. Okay, so this is actually a cubic or a cubed root. Okay, so with that being said, what you're going to do is you're still doing the same steps. So we're going to isolate our radical. Well, our radicals are both isolated already. So now my second step is to square both sides. But since this isn't a square root, this is a cubed root. The opposite of cubed root is to take something and cube it. Those are inverse operations, okay? So we're going to take each side and we're going to raise it to the third power. When we do that, that cubed root cancels out. So that's going to give me x minus 5 equals 7 minus x. Okay, so now my next step is to get x by itself. So we're going to move x's to one side and the numbers to the other. So we're going to add x to both sides. And that's going to give me 2x minus 5 equals 7. We're going to add 5 to both sides. And that's going to give me 2x equals 12. Still want to get x by itself, so we're going to divide by 2 on both sides. And that's going to give me x equals 6. That takes us up to step 3, and we know that step 4 is to check for extraneous solutions. So when we check, we're going to plug in 6 in for our x's. And we're going to do it on both sides. We're going to simplify what's underneath the radical. So 6 minus 5 is going to give us 1. And 7 minus 6 is going to give me 1. We can already see that these are equal. However, let's say that they're a little bit more challenging to see. The way to plug this into your calculator, because we know the cubic root of 1 is going to give us 1. So 1 is going to equal 1. But the way to plug this part into your calculator is to type parentheses 1, close parentheses, little caret button, raised to the 1 divided by 3 power. On this one, you don't have to plug this into the calculator if you know that the cubic root of 1 is 1. But if you wanted to plug this into your calculator, this is how you do it. Because not all calculators have a cubic function, like button. So you want to make sure that you know how to do that. Ready for the next one? Alright, so on number 4, our first step is to get the radical by itself. So it's attached to this negative 5. We notice that this negative 5 is outside of the radical. A lot of people don't notice that though, so here it is. There's that negative 5 outside that radical. So we're going to add 5 to both sides to get it by itself. When we do that, we're going to get the square root of 9x plus 55 equals x plus 5. Now, step 2 says to square both sides. We're going to take this side, we're going to square it. We're going to take this side, we're going to square it. So over here, we know that a square root and a square are going to cancel out. And that's going to give me 9x plus 55 equals, over here, this is saying x plus 5 times x plus 5. So this is saying x plus 5 times x plus 5. So when we multiply this out, we're going to get x times x and x times 5, 5 times x, and 5 times 5. This takes us up to our third step, and our third step is to solve. So what we're going to do is combine our like terms first. Okay, so when I combine my like terms over here, I'm going to combine those two. That's going to give me x squared plus 10x plus 25. And in order to solve for x, I'm going to move everything to one side. And the reason why I want to do that is because when we solve quadratics, we've got to have it in standard form, which means that we're going to have it in descending exponent order, and it's going to be set equal to 0 on one side. So we're going to move this 9x to the other side by subtracting it. And we're going to move this 55 to the other side by subtracting it. And when we do that, we're going to get x squared plus x minus 30. And over here, that's going to equal 0. Now, we're actually going to have to solve. And so this is the part where factoring comes in, or the quadratic formula comes in. So we can factor this guy by using the box, or using the big X. So we're going to take a times c, and that's going to give us negative 30. B is going to give us 1. And the two numbers that'll make that happen are 6 and negative 5. Okay? So when I write this out in factored form, that's going to give me x plus 6 times x minus 5. If I'm solving for x, what I'm going to do is I'm going to set both of these equal to 0 and solve. And so I'm going to add 5 to both sides, and that's going to give me x equals 5. Over here, I'm going to subtract 6 both sides, and that's going to give me x equals negative 6. So these are my two possible solutions. Okay, I say possible because on step 4, we've got to check it, right? So what we're going to do, so this is step 4, so we're going to check. So we're going to plug in x equals 6 and negative 5, right? That's what we found. Negative 6 and positive 5. That's right. My bad. Okay, and you got to be mindful of those negatives and positives, so make sure that you pay attention to those. Negative 6 and 5. Okay, so we're going to take negative 6 and we're going to plug it in for all of our x's on this equation. We're going to see if it's the same on both sides. So we do that. We get 9 times negative 6 plus 55 minus 5 equals negative 6. So over here, 9 times negative 6 gives me negative 54. Negative 54 plus 55 is going to give me 1. 1, square root of 1 is 1. And 1 minus 5 is negative 4. Now, my question is negative 4 equal to negative 6? No. So x equals negative 6 is not an answer. This guy's extraneous. Okay? And we're going to talk about how you write that answer out in just a second. Over here, x equals 5. So we're going to take 5 and we're going to plug it in for all of our x's in our equation. So 9 times 5. 9 times 5 is going to give me 40. 40 plus 55 is going to give me, 45. That was rough. 45 plus 55 gives me 100. Square root of 100 is 10. And 10 minus 5 is 5. Now my question to you is 5 equal to 5? Yes. And the reason why I have 5 over here is because, remember, in our original problem, we have equals x. So whatever x is, which in this case it's 5, we're going to plug that in here. Now, since it worked over here, but it didn't work over here, how we write out our answer is x equals 5. We don't even write out anything about x equals negative 6. Okay?